Now the next example is using the trial and improvement method to solve this equation. So it's similar to what we did before. It's a slightly different function, but we would have to draw the function y equals x cubed plus x squared and the function y equals 10. And we've got a computer version of this here. This is the curve x cubed plus x squared, and this is the line where y equals 10 that goes through here. And when we look at this through using the graph, we'll see that it's going to be around between 1.8 and 1.9. And then we'll use the same idea that we did in example 2 with the trial and improvement grid. So we know that 1.8 was too small, so let's try that one. 1.8. When we put that in, it's going to be 9.072, and it needs to equal 10, so this is too small. The comment here is that x has got to be greater than 1.8. And then we could try 1.9 just to check that that's going to be too large. And we put that in and we get 10.469. Oops. Oh, what's going on here? Oh, I know. Okay, and then we can say from there that that's too large. X must lie between the 1.8 and 1.9, which is like that. And we just continue the process. So remember what we did before, we had to do the midpoint, 1.85, and that generates 9.75, blah, blah, blah. And that's going to be too small, so therefore it's going to have to be between 1.85 and 1.9. And then we just keep going until we get closer and closer to it. So we'll try, let's say, 1.88. If we throw that in, we get 10.17 something something something, which is too large. So therefore, it must lie between 1.85 and 1.88. We'll try, let's say, if the next value has to be between 1.85 and 1.88. Let's try 1.87. That was 10.036, blah, 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 which is too large, so therefore it has to lie between 1.85 and 1.87. And then we would try 1.86. And throw that in, we get 9.89 something something. And therefore that's too small, it has to be between 1.86 and 1.87. And then finally we have to remember that midpoint again. Which one's it closer to? Is it 1.86 or 1.87? We would try 1.865, halfway between these two. And then when we put that in, we get 9.965, blah, 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 which is too small. Therefore, it must have been 1.87, which was the closer value. So I could write here, it's between these two. Oops. And then the comment, or the final answer would have to be then that x would equal 1.87 to 2 decimal places. And it's just something to note here. If you have one of our x cubed graphs that goes up and then down and then back up again, and it's asking for the point where where let's say it's asking for, let's say it's asking for this thing here, where the curve equals 0.1. If we draw the line y equals 0.1, it actually crosses it 3 times, so there would be 3 different answers. There's going to be one here, and one here. And there would be a case where you would only get 2 answers, which would be where it just touches the top of here and cuts it here, which will give you 2 other ones. It would be one at this point and then one at this point. And if it was anything larger than that, let's say at 1, then it's only going to equal, it's only going to have one solution. Ooh, what have I done there? It's going to have one solution down here. So that's just a note. Okay, have a go at the examples.